Salam sejahtera. Hari ini kita akan bincangkan pop quiz yang kedua yang menyentuh topik yang kedua, forces and motion. Okay, first question, complete the following table. So, kita dibagi jadual di sini, speed, definisi. So, apa definisi untuk speed? Kalau kita tengok kepada rumus speed, okay, speed ataupun laju sama dengan jarak bahagikan dengan masa. Okey, ini dalam bentuk formula. So, jadi kalau diminta definisi, jangan sekali-kali kita bagi dalam bentuk simbol lah. So, dalam bentuk ayatnya kita boleh tulis laju adalah kadar perubahan jarak. So, apa-apa yang dibahagi dengan masa, kita boleh guna perkataan kadar. Velocity pula dari segi rumus, okey, laju sama dengan sesaran dibahagikan dengan masa. Jadi, dalam bentuk ayatnya, itu sebenarnya ialah kadar perubahan sesaran. Okay, rate of change of displacement. Type of physical quantity, speed adalah kuantiti skala, manakala velocity pula adalah vektor. Okay, so alam yang kedua, define acceleration. So, I know that acceleration kalau dalam bentuk rumusnya A sama dengan V tolak U bahagikan dengan masa. Okay, so the best definition, sebab ini bahagi dengan masa, so itu ialah rate of change of, apa dia? Atas ini ialah velocity. So, we have final velocity minus initial velocity. So, here we can simply write rate of change of velocity. As simple as that. Alright, so we go to the third question. So, we are given here a taxi stop at a station to pick passengers up. It then moves and attain a velocity of 20 meters per second in 5 seconds. And you are to find what is the acceleration. So, if we read the question carefully, a taxi stop. So, that is my initial velocity is 0. Then, move and attain a velocity of 20 meters per second. So, that is my final velocity. That is 20 meters per second. In 5 seconds, so that is our time. So time there is 5 seconds. And we are to find what is the acceleration. So I know that A equal V minus U over T. So just plug in the value. V is 20, U is 0, divided by time is 5 seconds. So, I have here 20 over 5. That will give us the answer 4. 4 meter per second. So, how do I come up with meter per second square here? So, di atas sini, unitnya ialah meter per second. Bawah adalah second. Alright. So, meter per second bahagi dengan second sama dengan meter per second. So, darab 1 per second. So, I have meter per second kuasa 2. Ini bersamaan dengan meter second kuasa negatif 2. Okay, so that's how we comes up with the unit meter per second square. Alright, so let's move to question number 4. A ticker tape is divided into 5 parts, right? So I have part 1, here I have 2, second part, here is my third part, here is fourth, and then here is my fifth part. Alright, so I have 5 parts altogether, and if you look at the strip here, for each part I have 1, 2. So I have 2 tick. Okay, so for strip AB, the time I have 2 tick time 0.2 second. So the time there is 0.04 second. Alright, you are to find the acceleration. So I know that my acceleration A equal to V minus U over T. So I need to know what is my final velocity, my initial velocity, and my time. Alright, so since the strip is labeled A, B, C, D, E, F, so I would assume here as my initial velocity. So I will get my initial velocity here and my final velocity here. Alright, so let's find the initial velocity. So U equal to displacement over time. Displacement is given 2 centimeter, and then the time is 0.04 second. So that shall give you the answer 50 centimeter per second. Alright, and then my final velocity, that will be 10 cm, 10 centimeter divided by 0.04 second. You will get the answer 250 centimeter per second. Alright, so now I know my V, I know my U. So what is my T? So remember, from A to B, my initial velocity is here at this point here. That is my initial velocity, and my final velocity only exists at this point. So let's count. So I will use different color for that. I will use red. So here is 1, 2, 3, 4, 5, 6, 7, 8. So the time, right? So the time is 8 times 0.02 second. So you will end up with 0.16 second. So that is the time. So now let's find the acceleration. Alright, so A equal to V, V is 250 minus U is 50. We divide by 0.16 second. Okay, plug it into your calculator. You shall get the answer 1250 centimeter per second square. Okay, so the acceleration is 1250 centimeter per second square. Alright, so the part that you will always get it wrong is where is my U start and where is the V. Alright, so let's go to question number 5. Now we have a car traveling with a velocity of 15 meters per second. Accelerate uniformly at a rate of 5 meters per second square for 10 seconds. Calculate the displacement of the car. So first you need to fully understand the question. It says here a car traveling with a velocity of 15 meters per second. So what is this 15 meters per second? This is actually our initial velocity. and then it says it accelerates uniformly at a rate of 5 meters per second. So here is my acceleration, and 10 seconds of course is our time, and you are to find what is your displacement. Okay, so we call our linear equation for motion. So this one I have u, I have a, I have t, and I have to find s. So you shall know that s equal to ut plus 1 over 2 a t squared. So now just plug in the value. U is 15, t is 10, and then plus 1 over 2, a is 5 meter per second square, and then t again it is 10 square. So the answer to that question is 400 meter. All right, so that is my displacement. Okay, so remember you have to read the question carefully and try to understand what are the info given in the question and try to use all the info given. All right, now question number 6. So for this question, you are given a graph of displacements against time. So remember, when you are given the graph, you must look at two things. First is the gradient. Okay, that's number 1. And number 2, the area under the graph. So if I look at the gradient normally is y over x. Alright, there is y over x. So y over x in my graph, there is s over t. Okay, here is your y axis, here is your x axis. So y over t. So s over t. Okay, so that is our velocity. Velocity equal to displacement over time. If I check my area under the graph, okay, area under the graph, that will be x multiplied by y. Correct? The base multiplied by the height. That will give you the area under the graph. So what is my x? T, okay, and y in is our displacement. Alright, so I just rewrite according to alphabet order. There is st. So st means it's meaningless. It means nothing. But at the gradient, it will give us the value of the velocity. Alright, let's go over the question. Determine the velocity as he moved from O to A. Okay, from O to A. So O, the coordinate there is 0, 0. A, the coordinate is 5, 30. So how do I find the velocity? Alright, velocity is the gradient of the graph. Alright, so velocity equal to, okay, since we are familiar with y2 over y1, sorry, y2 minus y1 over x2 minus x1, so I will just write it as it is. Alright, so let's see our coordinate. So I have 30 minus 0 divided by 5 minus 0. So that will give you 6. And then the unit, my y is in meter. Okay, y in meter, and then x in second. Alright, so y in meter, x in second. So my unit is meter per second. So that is the velocity from point O to point A. Now, what happened at point AB? Now, at point AB, at any given time, let's say 6 seconds, 7 seconds, 8 seconds. If I read my graph, okay, my y-axis it always read 30. Here is also 30. 8 here is also 30. 10 is also 30. So my displacement there is always 30 at any given time. So what does this mean? It simply means that this guy is not moving. So he is at, oops, what happened? So he is at rest. Okay, or you can say not moving. Okay, so if he is at rest, so what is the velocity? That would be 0 velocity. So the best answer will be at rest, right? Now, at which point did he move in opposite direction, and then justify your answer. So initially we have shown that the gradient of the graph is velocity. So here I have positive gradient, positive velocity. Here I have v equal to 0. Here I have a positive velocity. But CD here I have a negative velocity. Alright, just by looking at how the line is slanted. Right? So here from C to D I have to go down and then I move to the right. Right? So moving down and then to the right. So moving down is negative. Going to the right is positive. So my gradient is y over x just now, right? So my y is negative, my x is positive. So my gradient is negative. Right? So if we look here, if you recall back, velocity is a vector quantity. So positive, we assume it's going to the right, to the front, okay, and going up. But a negative velocity, it simply means it's going in the opposite direction, left, down, or reverse, going backward. So which point did he move in opposite direction? So the answer would be C, D. Alright, so here the answer is C, D. And then justify your answer. What's your reason? Okay. Why CD is the answer? Because the velocity is the negative. Alright, because it has negative velocity. Alright, so here it is going backward. Now, D. Determine the total distance and the displacement. So what's the difference between distance and displacement? Distance is the path taken. Alright, the total path taken. Displacement, you need to know where it starts, where it stops. Alright, so the total distance traveled, if we look at the graph, it starts from here, it travels to here, that is 30. Alright, that is 30. I will use different color for that one. Maybe this color, this one. Okay, from O to A, the distance from O is 30. From A to B, not moving. Okay, B to C, the distance is 20. How do I know? Okay, B is at 30 and then it moves to C, it will at 50. So the difference is 20. And then from C going down to D, the distance here is 50. Alright, the distance travel. Distance displacement here, right? So 50. So what is the total? 50 plus 20 plus 50. So the total distance travel here would be 100 meter. However, for displacement, it is 0. Why 0? It starts from O, it return to 0 also. Okay, here point D here is 0, 0 15, 0. Alright, so the displacement is 0. Here the displacement here also 0. The value for S is 0. The value of S here is also 0. So I know that it go back to its original position. So what is the total displacement? It is 0. Alright, so I start from 0 and I end up with 0. Okay, we go to question number 7. Now we are given velocity time graph. Alright. Okay, what does the gradient give us? Alright. So gradient is y over x. Y is velocity and then x is time. Alright. So the gradient v over t, I can write this as v minus u over t, t2 minus t1, right? So that is our acceleration. And then the area under the graph. Okay, area time, base time the height. Okay, base I have time, and then multiply by the height. Height is v, but v I can write as displacement over time. So I can cancel the time. So I end up with displacement. So the area under the graph will give us the value of displacement. If you are not familiar with the formula, you can always check the unit. Okay, area. X is in second, right? Multiply by y is in meter per second. So meter per second. Second can be cancelled out. So we are left with meter. And meter is unit for displacement. Okay. So we go to the question. What happened at point AB? Okay, at point AB. So I have a flat line here. A flat line. So I know that my gradient is 0, right? So what is gradient just now? It refers to our acceleration. So what happened at point AB? So the answer to the question would be it has 0 acceleration. Okay, so the answer here I can write 0 acceleration. Or we can also write constant velocity, right? Because at any point my velocity is always 30. Alright, so it is constant velocity. Now identify at which point did deceleration occur. Determine the deceleration. Okay, so here I have deceleration. So what is deceleration? It is a negative acceleration. So how can I get my acceleration from this graph? Look at the gradient, right? So the gradient will give us the value of the value for our acceleration. So here going to the right, going up. So the gradient would be positive over positive. So that is for positive. Here is 0. Here would be a positive gradient, positive gradient, or positive acceleration, positive acceleration. What about CD here? So going from C to D, I have to move down and then I go to the right, right? So going down, so my acceleration is negative, going down to the right is positive, so here is negative. So I have a negative acceleration there. So this is actually deceleration. All right. So which point? So the answer there would be C, D. And then determine the deceleration. So find the gradient of the graph for the line CD. Alright, so A equal to y2 minus y1 over x2 minus x1, correct? Okay, so let us give the value for the coordinate. Okay, D, the coordinate D is 15, 0. C is 12, 50. Alright, so let's plug in the value. Okay, so I have 50 minus 0 divided by 12 minus 15. So you will end up with negative 16.67 meter per second squared. Alright, so how do I know that this is deceleration? I have a negative symbol in front here. So it shows that the object is slowing down. Okay, now we go to question C. Calculate the total displacement of the taxi cab. Alright, so how do I find displacement? So if we go to our note up here, displacement is actually the area under the graph. Okay, so calculate the area under the graph. So at this point here, I have a triangle, correct? Triangle. So the area is 1 over 2 times 5 times 30. Okay, so that is 75. Now next one, from here to here is 5. The height here is 30. So the area here is 5 times 30. So that is 150. And then here I have a trapezium, correct? Trapezium, the length of this line is 30. And then this one here is 50. Here is 2. Okay, so the formula for trapezium, the area of a trapezium is 1 over 2 and then multiply by 2 multiply by the summation of two parallel lines. So it's 30 plus 50. 30 plus 50. So that shall give the answer 80. And then the last one here, that is a triangle. Alright, so it's 1 over 2 time, okay, from here to here I have 3, and then from here to point C here I have 50. So 1 over 2 multiplied by 3 multiplied by 50. So here is 75 also. Alright, so the total displacement would be 75 plus 150 plus 80 plus 75. Okay, so the total displacement equals 75 just now, right? So 75 plus 150 and then plus 80 and then plus 75. So the total is 380 meter. So that is the total displacement. Okay, question D. Identify at which point did the taxi cab move in opposite direction and then justify your answer. Okay, now, so if we look at this graph, you are given velocity. And the question asks you at which point did the taxi cab going in the opposite direction. But if we look here, the value of my velocity, it is always positive value. Alright, the velocity is always positive. So what does this mean? If the velocity is always positive, because I don't see any negative velocity there, so it simply means that there is none. Okay, so the question asks at which point did the taxi cab move in opposite direction. So the answer to this question is none. Okay, why? Because there is no negative velocity. Alright, because the velocity is always positive. Okay, now we go to this question. What is inertia? So, inertia, the keyword that I will look from your answer would be this. I'm looking for the word tendency. Okay, so what is inertia? Tendency of an object at rest to remain at rest if in motion remains in motion with a uniform velocity. And some of you left out this one, unless, okay, unless acted upon by an external force. Alright, so I will look at this word, the tendency of an object, and then rest, remain rest, motion, remain in motion with uniform velocity. That is the second part. And then the third part is unless acted upon by an external force. There are three parts to it. Now, question 9. Which Newton's law of motion speaks about inertia? Okay, so you only learn 3 Newton law, first, second, and third. So just choose one. But for this one, Newton law of motion that speak about inertia, it refers to the first. Alright, so the first Newton law is about inertia. Second Newton law, it talk about F equals ma. And then the third Newton's law, it talk about For every reaction, there is a reaction. Same magnitude but different direction, opposite direction to be exact. Alright, now let's go to this question. A load is hung between thread X and thread Y attached to a ceiling. What happens if thread Y is pulled slowly? Explain your answer. So, if I pull Y slowly, so I am exerting force slowly into this thread. So that force will have the time going up here until thread X. So what happened? The force will be accumulated here, so the tension build up, and finally thread X will be broken. Alright, so what happened if thread Y is pulled slowly? Thread X will break. Okay, why thread X break? So the answer to that one, we can simply say the force exerted managed to travel to thread X. Okay, hence the tension in thread X increases until it breaks. Alright, that's what happened if we pull thread Y slowly. Now, what happened if we give a jerk to thread Y? So if we give a jerk to thread Y, so bear in mind that this load is at rest. Alright? So Newton's first law says that an object at rest will remain at rest. If in motion, will remain in motion. So if I jerk, so this load is initially at rest. So it will try to overcome the jerk given because it wants to be at rest. It will maintain its inertia of rest. Alright, so what happened? This load will not be moved. It won't be moved. It will not be moving. So meaning to say the force exerted down here, it will not be able to go up here. So I have my force only at this thread, this region here. So the tension build up and finally the thread breaks. Alright. So what happens if thread Y is pulled with a jerk? So the answer to that question would be thread Y breaks. Okay, why? Because the force exerted or the exerted force is stopped by the load. Okay, is stopped by the load which maintain its inertia at rest. Okay, therefore, hence, the tension in thread Y increases until it breaks. Okay, so that's how we write the answer for question 10b. Okay, we move on to question 11. State the principle of conservation of momentum. Okay, so the principle of conservation of momentum simply says that total momentum before a collision equals the total momentum after the collision. Okay, unless acted upon by an external force. So from here that we can write m1u1 plus m2u2, there is total momentum before. It must equal to the total momentum after. That will be m1v1 plus m2v2. Okay, this equation need not to be memorized actually. What you need to know by heart, what does the principle of conservation of momentum says? It simply says that the total momentum before collision must equal to the total momentum after the collision. Simple as that. Alright, now what is momentum? So momentum, in formula we normally write P, right? P equal to mv. So put this in word form, that will be momentum is the product of mass and velocity. So that is the definition for momentum. Okay, let's go to question number 13. So here I have a car of mass 400 kilogram moving at 10 meter per second collide with car B weighing 3000 kilogram moving in opposite direction at 8 meter per second. Okay, this is before the collision. Now after the collision, both cars are fused together. Alright, they are fused together. Determine the velocity and direction of the cars after the collision. So to answer this question, it's better for us to draw a table. So here I have before collision. Okay, here I have before collision, and then I have after. Okay, before collision, I have car A going to the right, let's say. But then car B, it says here, moving in opposite direction. So it's going to the left. Okay, so here mass is 4,000 kilogram. Velocity is 10 meter per second. Car B is 3,000 kilogram. And then the velocity is 8 meter per second. Okay, after the collision, both cars are fused together. So meaning car A are glued to car B. Okay, A and B. Alright, so do I know the mass? Well, they are fused together, so the mass must be 4,000 plus 3,000. So the mass here would be 7,000 kilogram. And then do I know the velocity? No, I do not know the velocity. Alright, so next, count or calculate the momentum. So momentum is mass times velocity. Alright, so car A is going to the right. So that will be 4,000. Mass is 4,000 times the velocity, that is 10. Okay, plus the total momentum before the collision, right? So plus momentum of car B. Okay, car B, the mass is 3,000. The velocity is 8, but look at the direction, it's going to the left. So here I have negative 8. So the total momentum before the collision is 16,000 kilogram meter per second. And what about the total momentum after the collision? Alright, so again it's mass times velocity, right? So the mass is 7,000 times the velocity is something that we need to find out. So this is the total momentum after the collision, and this here is the total momentum before the collision. What comes next is the principle of conservation of momentum, which simply says the total momentum before the collision must equal the total momentum after the collision. So before must equal to after. So calculate what is V. So V, if you do the calculation right, you shall get the answer 2.286 meter per second. So here I can see my velocity is positive. So it's going to which direction? Okay, it's moving to the right. Okay, in the directions of car A. Alright, so that's how we solve the question. So it's easier if you draw the free body diagram and then you try to analyze and synthesize everything. Okay, so I hope you understand how it is worked out. Now we go to the last question. A bullet of mass 10 gram is shot from a gun of mass 1 kilogram with a velocity of 200 meter per second. And again, you are to calculate the velocity of the recoil of the gun after firing. Alright, so I see inconsistency in terms of the mass. here I have gram, and here I have kilogram. Okay, so for the purpose of calculation, I am going to convert this gram into kilogram. Alright, so 10 gram is equivalent to 0.01 kilogram. Alright, that is what 10 gram is equivalent to in kilogram. So what happened before and what happened after. Alright, so before I have my pistols, inside here is my bullet. Okay, here my initial velocity is 0. Right? And then the mass is equal to the mass of the gun plus the mass of the bullet. Right? So it's 1 kilogram plus 0.01 kilogram. So that is 1.01. But actually the total momentum before the collision, well, m multiplied by u, it is 0. Okay, because the velocity is 0, so definitely the total momentum before the collision is 0. And what happened after? Alright, so here is my gun, and I know that bullet will come out from the gun. Alright, so this gun is 1 kilogram. I don't know what is the velocity, but for this bullet, the mass is 0.01 kilogram. Velocity is 200 meter per second. So the total momentum after the collision, so I have mass 1 multiplied by velocity v, okay, plus 0.01 multiplied by 200. Okay, so that will give you v plus 2. Okay, so what comes next? Principle of conservation of momentum. So here, before collision, the total momentum is 0. After the collision, the total momentum is v plus 2. So what is my v? That is negative 2 meter per second. So what does this negative sign tells us? It simply tells us that the gun is moving where? The bullet is going to the right, right? So this negative sign here, it simply means that the gun moving backward. This is what we call as recoil. Alright, so that's how we answer the question. So what you need to do next, right, is to do the correction and to pass up it maybe on Monday perhaps, or I'll text you guys again later. Right, make sure you do the correction. You can come to school and pick up your exam, your pop quiz paper anytime, today or tomorrow or even Friday. So when you come to the school and pick your pop quiz 2 up, I will give you new thing to do. Okay, so that's all for today. So we'll see you again next time.